we're good to go. Hello. That's okay. I think we're good. No, I don't like this. Oh. All right, that looks like it's better. Everyone can hear me? We're good? Yeah? Awesome. Okay, so like I said, I'm going to be starting every class a little late for the reason that you guys all probably have your classes in MC and like those areas, and this building is quite a bit away. So, yeah, every class, 5 minutes late. Okay, welcome. Welcome to CS115. This is third week, I think. Fourth week, I'm not really sure. We're on module 2. There's 10 modules in this course, and up till now, what we've covered is module 1 and half of module 2. Module 1 essentially talks about what Dr. Racket is, how do we turn math into Dr. Racket expressions, and then we also went over tracing. How do we take a program and take an expression from a Racket expression and evaluate it all the way down to a value that cannot be simplified any further. Then we went into module 2, which was essentially about the design recipe. We talked about, well, programming languages are a way for us to communicate with the computer on how, just a way for us to tell the computer what to do. And computers only read ones and zeros, while we read like actual language. And a programming language is kind of a nice middle ground. And the design recipe, the goal for the design recipe was to essentially make it so humans can communicate with other humans on the code that they're writing. And we do this through the purpose, the contract, examples, test cases, and maybe a require statement, if it's necessary. And that's kind of all we've done so far. Taken math, turned it into Dr. Racket, taken a Dr. Racket expression, simplified it down to a value, and then a design recipe that essentially says, what does my program do? Okay? Now I keep saying, this course gets started at Module 5, and before Module 5, it should be more relatively straightforward. And I really mean that. Up till now, or up till Module 5, all we're going to be doing is showing you guys other data types and how to work with those data types. Currently, we've gone over integers, natural numbers, rational numbers, and just different kinds of numbers. And nothing we've done so far has been something your calculator cannot do. But up till now, from now and up till Module 5, we're going to be introducing other kinds of data, and we're going to show how Dr. Racket can actually be a language that's more expressive than just your calculator. And hopefully today, we see some examples of that. Okay. Now, every class I like to start off with an example of what we covered last class. However, last class, all we did was examples, so I can't really give a good example of those examples, but I'll try to give one halfway through the class today, because yeah, we didn't really cover any new material last class. Well, that's kind of a lie. We briefly introduced the string data type. So get familiar with this, because the string data type is probably the most common one you're going to use throughout this course, and if you take further computer science courses, this is the data type that most of your variables are going to be of, the type that most of your variables are going to be of. And what is a string? All a string is a way for a computer or a programming language to write words. Now, it can have punctuation in them and other characters, but generally speaking, it's a way to write a word in a programming language. And more specifically, a string is made up of letters, numbers, blanks, which are spaces essentially, and punctuation marks. And how do we know whether something's a string or not? The way we can tell is if you have the string enclosed in quotation marks. So start quotation is the starting of your string, and then end quotation is the ending of your string. Kind of like the 3 examples there. Hat, this is a string, and module 2. Now what if we wanted a quotation mark within our string? How do we do that? No one should know how to do that. If you guys know how to do that, you probably should be in this course, because I haven't gotten over that yet. But there is a way to include characters like a quotation mark within your string, and we're going to show you how to do that later on. But for now, all you need to know is a string is simply, well, numbers, letters, blanks, and punctuation marks. Any question about what a string is? You're going to use this for the rest of your course and 116 and everywhere else you do computer science. So make sure you understand what a string is. Okay? Now, there are three important operations that are associated with strings. You have to know these. Kind of like we have plus, multiply, subtract. These are all operations we can do on numbers. We can write other functions. Last class we showed an example of a function that took in two digits, or two-digit numbers, and it gave us the biggest digit of either of these numbers and turned that into one number. So there's other operations we can do on integers, but for the most part, you guys have seen multiplication, exponentiation, all these kinds of operations. Strings also have built-in operations, and these are the three most important ones. So string append is probably the most basic one. It takes two strings, and it simply just puts them together in one string. Pretty straightforward. String length should also be kind of straightforward. It just counts how many characters are within the quotation mark, and then it outputs that number. So in this case, it's Length, and that's 6. So there's 6 characters within that string, and therefore string length outputs 6. Okay? Yeah?
Will each count the space?
Yes, that's a good question. So punctuation marks and spaces, they all count. So in the example, the second example, this is a string. What would the string length of that be? Let me figure it out first. Hold on. Okay, I got it. What's the string length of that? Wait, hold on, let me use a picture. Okay, I got it. What's the string length? Yell it out. 17, right? Because the spaces count and the period counts at the end. Who here does not know how the string length of this is a string period is 17? It's just everything that's inside there. Spaces count, punctuation counts, everything counts. Okay? Alright. Now substring is definitely a little bit more complicated, so let's actually spend some time understanding what substring does. Okay, so let me write a string out and show you guys essentially the difference. So actually, no, first let me just show you what the contract, or what substring looks like. So the function substring, its first argument is going to be a string. So it's going to be a string, and the next one is going to be a nat. Actually, it should count. String, nat, and nat. Actually, that's not a contract. This is not a contract. The contract would be substring, colon, it consumes an str, a nat, let's zoom in here. It consumes an str, a nat, and a nat, and it outputs an str. Okay? So, an example of this would be substring of, let's just say hello. And then we'll pass in 2 and 4. Okay, and notice how this is a string, this is a natural number, and this is a natural number. And what is this going to output? Well, it's going to output a string. It's going to output some sort of string. Okay, so what string are we going to output? Well, did I make a mistake? No? I'm seeing blank faces. No? Okay, we're good. So to understand what this outputs, we need to understand what these numbers mean in the context of a string. So let's just write hello in really big letters here. Okay? Now, to determine, well, we need to understand the concept of an index. The concept of an index is essentially the idea of what index is essentially what character are we on. So H is going to be at the index 0, E is at the index 1, L and L are on the index 2 and 3, and then O is at the index 4. So essentially this is a way for us to count. And this is your first time seeing this, but in computer science, we almost always start counting at 0. Now, regularly, I'm sure you guys have seen counting in other ways. When you count, it would just be like, oh, this is the first one, this is the second one, third, fourth, and fifth. You're not wrong, but, and you'll see why later on, but in computer science, we always start with 0. So this would be at the 0th index, this would be at the first index, second index, third index, fourth index. You don't actually need to know what index means, it's just a way for us to reference where we are in the string. That's all you really need to understand for the word index. Okay, so if we have the string defined as this, when we pass in 2 and 4, what this tells us is we want everything within this string starting at index 2, or starting at this index, and going to, but not including this index. Okay, so that's very important. We start here, and we include whatever is at this index, but we do not include what's at this index. Okay, so if we start at 2, that's L. So it's going to be a string consisting of L, and so we're going to include 2, we're going to include 3 because it's not 4, and the O, because it's at index 4, it's up to and not including this index. So our answer would be LL. Any questions about that? Okay, so let's just see some examples. So Caterpillar at 5 and 9. Well, Caterpillar has the C at 0, the A at 1, the T at 2, and then E is 3, R is 4, P is going to be a 5, and then I is 6, L is 7, L is 7, L is 8, A is 9. So we're going up to, we're starting from P, and we're going up to A, but not including A. Because we go up to the last one, but we don't include it. Okay? Does that make sense to everyone? That's why we get filled. Now, let's look at the cat example. We start at index 0, and we go up to, but don't include index 0. So we start at C, and we include everything up to, but not including C. So empty. It's the empty string. Because we don't include whatever the final number, we don't include up to this index. Does that make sense? Now in the last, yeah?
How do you distinguish between an empty string and a string that just has a space and nothing else?
Good question. And the only way to actually, so the question was, how do you distinguish between an empty string and something that only has a space? And, well, let's see it. So I'm going to define empty string as empty and define space string as space. And the only real way to distinguish is, well, that's one way, you can just look at them. But if you do string length on empty string, you're going to get 0. But if we do string length on space string, we get 1. Now, the only real way to do, like, that's how I distinguish them. I just do string length, and the empty string will always be the string length of 0. But realistically, if you look at them, there necessarily needs to be like a space. And when you're writing, like, say if you're writing a midterm, how do you have a space in your midterm because you're writing them by hand? Well, be more flexible there, obviously. So yeah, if you want to include a space on your midterm and you're writing the string by hand, just put enough space to make it seem like there's a space, and we will still be flexible, just because we know handwritten programming is not as easy as doing it on a computer. That was a good question. Any other questions? So string's really important, and the substring operation is especially important because, well, I mean, you'll see in your assignment why. Now the last one, you know how I said the contract is, it takes in a string and then 2 natural numbers? It's kind of a lie. It's possible for a substring to take in a string and just 1 natural number. And if it takes in 1 natural number, it's just the first argument. So you're saying, if you do substring from nowhere to 3, you're saying start at 3 and go all the way to the end. So we start at, well, n is at 0, O is at 1, W is at 2, H is at 3, so we start at 3, and we go all the way to the end. Okay? Does it make sense? Strings are important, so we gotta make sure we understand this. Any questions about these? And these are the three most important built-in operations for strings. Make sure you understand what string append, string length, and substring do. Okay? Now, as an exercise, let's write the contract for string length. So, what would the contract for string length look like? What do we do? String length. What does it consume? Not that. It consumes a string. What does it produce? Not an int. It produces a nat. Because this output has to be a length, has to be somewhere between 0, well, a positive number or 0. And it can't be a decimal. You can't have a string length being 5.5. That doesn't make sense. And an example would be string length of hello would return 5. That's the string. That's the natural number outputted. Make sense? Yeah?
So it counts 5 and also 0.
Yeah, so the length will always still be how many characters there are, even though we start at 0. That's a good question, actually. And you will probably on your assignments be confused sometimes where you think it's starting at 1, but it's starting at 0. I know I got confused when I first took this course. I mean, I failed, so hopefully you guys won't be as confused as I am, but it is definitely kind of confusing. I didn't fail this course, I passed this. I failed the next one. It's gotta. Anyways, no, we're not gonna go there yet. I do actually have a speech that I always gave to myself when I was in first year and I failed all these courses, and it really helped me through. And I was thinking of telling you guys that speech, but I will, but we have to save it after the midterm because let's just say after the midterm, some of you guys are gonna need to hear it. It's kind of unfortunate, but well, that's kind of the law of averages. You know what? Actually, we're gonna take a small detour. I'm gonna tell you guys a funny story. So, I keep saying how I like statistics, and there's actually a kind of an interesting reason. I play poker, and statistics is very often used in poker. But let me just tell you an interesting statistic for this course. So, as professors, we aim for a class average of around 70 to 75. Okay? So, class average is going to be somewhere between 70 to 75%. Okay? So what that means is take all your grades, add them all up, divide by how many students there are, and our goal is to make sure the class average is somewhere between 70 and 75. And the reason for that is because at that point the course is not too easy, so we're still inviting talented students in, and it's not too hard where you can still be like an arts major or like a humanities major and take this course and not be overwhelmed. But what that means is there's going to be students that most of you guys are probably going to get in the ballpark of 70 to 75, but there will be students that get 90s. And, good job, that's great, but for every student that gets a 90, there's going to be a student that I'm probably going to see here next term. And it's kind of the sad truth, but in the end of the day, if we're aiming for a class average of 70 to 75, and say there's 100 students in the class, that generally means 5 to 10 of you guys are going to fail. And considering we have around 300 students in this class, well, you can do the math. So I hope you're not part of that group, but the sad truth is there's going to be at least 10 of you guys that I'll see here next year. Sorry, it's a sad truth. That's just how stats work. I'm telling you, this is statistics. This is not me, it's not my opinion. That's statistics. That's got nothing to do with me. If class average is 70, 10 of you guys will fail. Sorry. Anyways, moving on. Don't be that 10. Be motivated. Don't be that part of that 10 people. There's going to be 10 of you, but don't be part of that 10 people as an individual. Okay? Moving on. Okay, so hopefully that motivated you guys to pay attention. So, those are the 3 basic functions with strings. Now, let's see some more complicated examples. Well, actually, no. First, let's just start. This is kind of what I was stating earlier. Substring takes in 3 values: t, which is a string, start and stop, and then it goes from start all the way to stop, but not including stop. And some requirements on these variables are that start needs to be between 0 and stop needs to be between start and the length of the string. Does that make sense? Yeah?
Professor, regarding these spatial values, there is the empty string which has a space in it. Doesn't it have?
It does not have a space in it.
Oh.
So the empty string is just a quotation mark followed by a quotation mark. To have a space in your string, you would have a quotation mark, press the space key, and then press the quotation mark key again. So there is a difference. And like it is confusing, but there is a difference between the empty string and a space string. Okay? I'm going over this a little slowly, but it's very important, so that's kind of why. Okay. Oh, we have a third question. Oh my god, we have a third question today? I did not know that. Okay, I gotta figure this answer out myself. Alright, give me a second. Let me get all this software started. So the room frequency is AC. And you should be able to enter now. You have a minute and a half. For this one, I might give it a little longer, just because it's probably a little more challenging. And I don't want anyone taking this to Dr. Rackett. If you copy paste this code to Dr. Rackett, I'll be very upset. I won't know, so I won't be upset, but I mean, never mind. Really testing whether you paid attention in the last 20 minutes. Give you guys one more minute. Seconds. All right. I'll give you guys some more time. I feel like this one's a little harder. Yeah, another minute. Okay, 15 seconds. Okay. Now, okay. 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 All right. Now this is the part where I figure out whether I'm doing a good job of teaching or not. Okay. So. Oh god, this is always the scariest part for me, just pressing this button. I really hope you guys pay attention. I'm like, okay, let's see. Yes. All right. It is A. It is definitely A. All right. Let's go over why it's A though. Okay. Okay. So, why is this A? Well, what is S2? S2 is the string append of S1 and S1. So S2 is the string A, B, C, D, E, F, A, B, C, D, E, F. Actually, let me write this down somewhere. This is probably better if I write this down. So, S2. So, I'm just going to write this mathematically. S2 is A, B, C, D, E, F. A, B, C, D, E, F. Okay, so this is obviously not how you write this in scheme notation, but I'm writing this, well, in a simpler notation. Okay? And then S3 is the substring of S2 from 3 to 6. Okay? So it's an substring from S2 from 3 to 6. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, whatever. So it's starting at 3 and going up to but not including 6. So it's this part right here. So S3 equals D, E, F. Okay? Then we have S4 as the substring of S3 from 1 to string length of S3, 1 minus that. Okay, so just to show you how this would look like. Again, I'm writing this in mathematical notation, so it's the substring of S3 from 1 to this location. So substring of S3 from 1. So again, this is 0, 1, 2. So we're going to start at 1. We're going to start right here. So S5, or sorry, well, not S5, but the result is going to be something starting at E. And then where are we going to? We're going to the string length of S3, minus 1. And this is obviously not good notation, but hopefully you guys can understand what I'm doing here. So the string length of S3, it's 3. Okay? 1 minus 3 is 2. So we're going from 1. So this is essentially the same thing as writing substring of S3 from 1 to 2. Okay? And so that means we're starting here, and we're going up to here, but not including this. So we go up to this F, but we're not going to include it. So it's just E. Cool? Any questions? Make sense? Alright. Are we good? Any questions? Cool. Alright. The clicker answers are getting better. I'm happy. I'm thoroughly happy with that. Okay. Okay. So now what we're going to do is we're going to see our first function that actually uses strings. Up till now, all the functions we've written have kind of just used integers, numbers, and that sort of stuff. We're actually going to see a function that uses strings now. And this function is going to be called swap parts. Okay? And what I'm going to do now is I'm going to actually try to get you guys, I'm going to give you guys 5 minutes to try to implement this, and then we're going to do it together. So what does this function do? It will exchange the front and the back part of the string. Now well, let me just see if they give you an example here, because I want you guys to try this out. Yes, they do. Okay. Okay. So yeah, it exchanges the front and the back part of the string, and if the length of the string is odd, then the front will be shorter than the back. Some examples of this are, if you have Angel, you're going to take the first half, and you're just going to put it at the back half. And in this case, because it's an odd length string, the first half is shorter than the last half. In this case, the first half is going to be AN, and the last half is going to be GLA. And the second example, since it's an even length string, the first half is going to be POTS, and the last half is going to be HOTS, HOTS. And therefore, when we swap them, we get, well, gleam and hotspots. Okay? Now, I want you guys to take 5 minutes to try to implement this. And the real reason for that is because I want to go to the drink, so I'll be back. But try implementing this, and I will be back.
这老师挺搞笑。
You go washroom, right? When you're washing hands, the actually the speakers, the water sound just. Oh, really? Ah, well, it is what it is. Did you solve it? Come on. Wait, so wait, what happened to the speakers?
No, you were washing hands, right?
Oh, you guys heard it?
Yeah.
Whatever. It is what it is. Note to self, turn this off next time I go. Okay, solve it. I'm dead serious. Solve it. I'm not solving it, well, I will, but like, still, solve it. I'm not gonna, like, I see you guys are looking and you're not like writing, so like, I'm not gonna continue until I see it, at least fake writing or something, so I know you're trying to solve it, because I'm not gonna continue until I see you guys trying to solve it. I guess you have your computers in front of you, so you could do it on the computer. No, seriously, like, this class should be interactive. I want you guys to try practicing with me. Like, coming to class should be a learning experience. You guys are already walking so far out of your way to come to optometry. Might as well make it a good learning experience. I'm like really glad I didn't have a conversation with someone out there. That would have not been fun for you guys listening in on that.